Hello, welcome back to the channel. So let's move on to a new topic which is about geometric series. So geometric series is a special kind of series which follows this pattern over here. So in geometric series, every two consecutive terms have a common factor, which means that doesn't matter whichever two consecutive terms you pick, you can get the second term by multiplying a number with the first term. So for example, if we pick these two terms over here, the second and the third term, if I multiply r to the second term, I get the next term, and I can keep on repeating the same process, multiply r to get the next term as well. And in this case, the number that we multiply with is known as the common ratio, and a is known as your first term. So you start with your first term and you have a common ratio which you can multiply in order to build your series in this case, right? So whenever you have this pattern over here, this series is a special kind of series which is known as the geometric series, right? So now since we are dealing with series, we are more concerned about calculating the sum of a geometric series, right? And now we need a special formula for that. A formula which is easy to compute rather than solving the sum by adding those individual terms in this case. So in this video, we'll cover the process in order to derive the formula for S of n, and then in the next video, we'll solve an example which is based on Sn in this case. So we know that our Sn is basically a plus ar plus ar square, so on until ar n minus 1. So capital N minus 1 because it's S of capital N plus ar capital N, right? And there is a trick to solve this. There is a trick to simplify this sum expression so that we can get rid of most of the terms over here and have a very small formula for the sum computation. The process is, you can notice that if we multiply r to our Sn expression, this term will become ar, this term will become ar square, this term will become ar cube. So if we multiply this series with r, you can get most of the terms again, right? So let's do that. If we multiply our Sn with r, our first term over here will become ar, right? Because we are multiplying r with every individual term now. So this becomes ar. Let's write it below ar so that it's easy to visualize. So this becomes ar. Let's write it. So if we multiply a with r, we get ar. If we multiply r with ar, we get ar square. And similarly, if we keep on multiplying the r with all these individual terms, we would have an ar to the power n minus 2 term, which will give us ar to the power n minus 1. Multiplying r to this, we will have ar to the power n. And then if we multiply, at last if we multiply r with ar to the power n, we will get an additional term which is ar to the power n plus 1 in this case, right? And now you can clearly notice that if we subtract this sum from this sum over here, we can get rid of most of these terms over here, right? Right? So now if we do that, let's do rsn minus sn. So if we do that, we can cancel out most of these terms over here. So ar will cancel out, ar square will cancel out, and all these terms in between will also cancel out until ar to the power n, right? Such that we will be only left with this minus this in this case, right? So we will have ar to the power n plus 1 minus a in this case. And now we can take Sn common in this case. So it will be Sn times r minus 1. The right hand side will be ar to the power n plus 1 minus 1. So now you have a very small formula for your S of n, which is basically a times r to the power n plus 1 minus 1 upon r minus 1 in this case. So this is the sum formula for a geometric series. So whenever you have a geometric series which has n finite terms, you can always use this formula to calculate the sum rather than calculating the sum by individually summing up all the terms in the series. So in this case, we have the sum formula, but you see that this sum formula has a discontinuity at r equals 1, right? So now this formula is only valid for r not equal to 1, right? And now you know that your series is basically a plus ar plus ar square, so on until ar n minus 1, ar to the power n. So what happens when r is equal to 1? When our r is equal to 1, our series will get rid of our r's, because we know that 1 to the power of a positive number is 1. So our series will be then simplified to, so Sn will be a plus a plus a plus a, so on for n plus 1 terms, right? So there would be n plus 1 terms because we are starting from a and ending at ar to the power n, right? So in this case, our S of n will simply be a times n plus 1, right? Because we are adding a n plus 1 times. That's it, right? So now we have a clear expression for our sum of a geometric series. When our common ratio is not equal to 1, we will use this formula. If our common ratio is equal to 1, we'll use this formula over here, which can also be noticed in this case over here. You know that your sum of a geometric series follows this formula if your common ratio is not equal to 1, but if your common ratio is equal to 1, you follow this formula over here. You will clearly notice that they have 1 minus r expressions in the numerator and in the denominator. We have the same thing as well. If you take the negative sign common in the numerator and the denominator, you get 1 minus r instead of r minus 1, right? So that's it for this video. In this video, we covered the sum of a geometric series, and we'll use all these concepts in the next video to calculate this sum over here, right? So stay tuned for that. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.